In this video, we're going to write a mini program which will combine most of everything we have used in this section and the last section. So in this video, we're going to write what is called a prime number checker. The prime number checker will tell us whether a number is prime or not. A prime number is a number which is only divisible by the number 1 and itself. So I have listed a few prime numbers already, so 2, 3, 5, 7, 11, 13, and so on. Notice that all the numbers that are not included in this list have factors which divide into it. So for instance, 10 is not on the list because 10 has the factors 2 and 5 which divide into it. And furthermore, I would like to add that 1 by definition is not considered a prime number. So let's get started on writing our prime number checker. To begin writing our prime number checker, we are going to need a number to check. And we're going to get that number from user input, like so. The next thing I want to do is create a list called divisors. And divisors will be a list that contains all the numbers that divide evenly into n. So now let's test to see which numbers divide evenly into n. So for a divisor in the range 2 up to n, I did not start at 1 because 1 trivially divides into everything. I'm going up to n non-inclusive. So we're checking all the numbers from 2 up to n non-inclusive to see if those will divide n evenly. So if n mod divisor is equal to 0, meaning this divisor divides into n, then let's append that divisor to our divisors list. There we go. Now once the loop is completed, what we can do is check if the length of our divisors is equal to 0. This means our number is prime because there are no divisors. So we can print something like is prime and then format and give it the number n. Else, or otherwise, we can say, oh, this number is not prime because we're going to pass in the list because these numbers divide n. So let's format that also. So n, our list of divisors, and n again. So here we just tell the user which numbers divide n to make it not prime. Awesome. Let's give this program a test. So here I am in the terminal and I run our program. It asks me for a number. I type 9. 9 is not prime because 3 divide 9. Let's try another one. How about 2? It says 2 is prime. Let's try 1. 1 is not prime. It says 1 is prime. So we have an issue right here. And how about we try another one, perhaps -7. It says -7 is prime. Uh-oh. So what's happening is we are not checking to see if our number is greater than or equal to 2. Because everything less than 2 is not prime. So if n is greater than or equal to 2, then we want to execute the following. Otherwise, we know that our number is not prime. So instead of me typing all those numbers in again, let me just create a for loop which will loop from -10 to 10, so we cover a decent amount of numbers, and let's just print that out right there. So if I run this, we get a lot of output. Oh, I apparently forgot to format. So dot format, put our number n, rerun this, and we get -10 is not prime, and they're not prime all the way up to 1, and 2 and 3 are prime, and then once we get into the positive numbers, you can start seeing that it's starting to spit out the numbers which are not prime and their divisors. So 6 is not prime because 2 and 3 divide into 6, and so on. So it looks like our program is working correctly. In this section, we looked at how to create a for loop, what a while loop is and how to use one, what iterables are, and how to use loops and conditionals together. In the next section, we are going to use everything we have learned so far to create our own functions so that we can reuse Python code efficiently and make our programs easier to understand.